Hey guys, so I'm going to show you just a little reminder of how to find the charge and the PI, the isoelectric point of a peptide. And the one we're going to use here is lyse, glue, and hist. And just remember, we have our terminuses here. Okay, so remember, right, you have to remember the list of amino acids that we need to remember the pKa's for. We have our positively charged amino acids, right, our last heckin' aminos, which is lysine, histidine, and arginine, right? We have our negatively charged ones, which are glutamate and aspartate. And then you have your two kind of outliers, which kind of trip people up, but those are cysteine and tyrosine. And those usually carry a negative charge along with these. And these usually, these are your positive ones. All right, you double check that. Aspartate, cysteine, glutamate, and tyrosine, as well as carboxyl, and then yeah, and then yeah. So that's kind of the list that we need to remember. I remember the last heckin' aminos. Histidine is going to be about 6. Lysine's about 10.5, along with tyrosine. Arginine is about 12. Glutamate, aspartate are around 4 because they have the carboxyl groups. And cysteine, which has 8 letters in it, is going to have about 8. 8.2 to be exact. So those are our pKa values. That's everything we need to know here, okay? So the first thing we want to do with this polypeptide is make sure that everything is protonated, okay? So lysine, positive charge in the protonated form. And these are going to be... So the thing is that protonated, these, and that includes the NH3+, are going to carry a positive charge. When any of these are protonated, however, they're just going to be neutral, okay? So we're going to protonate everything. So we have a lysine. That's protonated. That's going to be a +1. Our glutamate is going to be neutral. Our histidine is going to carry a +1 charge. Our carboxyl is going to be neutral. I mean, you can already see it's neutral. And then our amino terminus is going to have a +1 also, okay? So in a fully, remember, that's step number 1, protonate everything. All right, now we're going to do our, what I call the pKa lineup, all right? And we're going to need everything here. And we're going to put this in order of pKa. There's 2 pKa's I haven't included here, and I'm going to show you a shortcut. When you think of a steering wheel, when you first learned how to drive, where do you put your hands? At 10 and at 2. And what are our terminals? NH3, which is 10, carboxyl, which is around 2. All right, you will never forget those. So that's your pKa of 10. This is your pKa of 2. So we're going to put everything in order. So our lowest pKa is our carboxyl here. Followed by, let's just write them all here, 10.5, round 4. Histidine, round 6. Hopefully I'm remembering those all correctly. So we have a 2. We have a 4, we have a 6, we have a 10, We have a 10.5. Now this exactly is 9.6, right? And this exactly is 2.3 if we really want to be specific. But approximate numbers should be fine here. And then we have our histidine. No, I think we're good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5 numbers here. So here's the thing. Remember that if we're looking at a graph of pH, and remember, as we go to the left, the right, we have an increase of OH minus. As our pH goes up, our H plus goes down. All right. This is about 2, and this is about 10 in terms of pKa's. And just remember, as you're going to the right, I call what's called LOP. You're losing protons, right? So when you're in a fully protonated form, you're really looking at like a pH of like 0, like here, right? Lower than any pKa. Nothing has lost a proton yet. That is what we call protonation, right? So in that case, when we're at +3, which was our total charge, what that means, when we're at +3, we're here. We haven't hit the pKa of carboxyl. When we do cross that pKa, what do we get to? +2. We lost the proton, right? That carboxyl is now, well, you have to know the rule of 9s to know exactly when. But for simplicity's sake, we now have lost charge, so now we're at +2. All right, our 4 was what? Was glutamate, and our 6 was histidine. Our 10 is that NH3. All right, as we keep moving, as we move one more, we have a +1. As we move one more, we have a 0. All right, and then if we move one more, we'll have a -1. So the numbers that we want are on both sides of the 0, which is going to be this and this. These are the two pKa values that we want to average, giving us our Pi of 8. All right, there you have it.